I think I'll try to do is, the geometry of the problem doesn't really matter except a little bit for the adjacency. The adjacency of sectors. It doesn't matter if any of the sectors are larger or smaller than the others. But what I might try and do is just see if I can construct a distribution of the points which violates some of these conditions, some of these statements, and then maybe along the way I'll come up with reasoning for why they must be true. So some sector contains at least 5 points. Well, if I want to break that, then I need to make the sectors hold the fewest number of points possible. And to do that, I should equally distribute them as best as possible. But you can see, once I put 20 of the points down equally distributed, I have to put another point in one of the sectors. And so I have one sector, some sector contains at least 5 points. And there's not going to be any other way of distributing these. If I take this as the starting position and I move points one at a time from one sector to another one, then no matter what I do, there will always be at least one sector with more than 5 points. If I move things between these four, then nothing changes. If I ever move one out of here, this will go down, but the other one will go up. Okay, so statement A is going to be true. Some sector contains at most 3 of the points. So that's statement 2. So that's clearly not true, right? Even before I erase these points, every sector contains more than 3 points. Oh, sorry, that's not A. It's option 1, which is correct. Statement 2 is not correct. I have just demonstrated a distribution of the points, which doesn't work. And statement 3. This might take a little bit more thinking. Some pair of adjacent sectors contains a total of at least 9 of the points. So let's see if we can try to break that one. If I take my original distribution, if I move this one over here, I think it looks like this one might end up being true as well. How would I show certainly that this is true? Some pair of adjacent sectors contains a total of at least 9. So for this distribution, that statement is true because this pair of sectors has 9 points, as does this one. If I move a point from one sector to another, it's still true. So if I want to try and come up with an example where this statement is false, then I need all pairs to have at most 8 points. So I could do something like this, but then of course that's only 20 points. If I add one more point, it doesn't work. But what if the initial distribution is something like this? So I've taken 3 points out. If I add 1, 2, 3, I'm not sure if I can come up with a fully, like a proper rigorous proof for why this is true, but if each pair of adjacents contains at most 8, so I have 8 there, 8 there, 8 there, 8 there, and 8 there, then that's not enough. That's only 20 points in total, right? Because if it's 8, 8, 8, 8, and 8, then that's 8 times 5, but I've double counted each sector, so I should divide by 2, and that's only 20 points. So there has to be at least one pair that contains more than 8. In fact, what I've just said here is basically the outline of a rigorous proof. So statement 3 is also true. In terms of the multiple choice answers, this corresponds to D. Statements 1 and 3 are true. So a nice little problem in, some logical deduction, understanding how the pigeonhole principle works. But I guess if you want to sort of come up with examples that try to be counterexamples to the statements, you have to kind of know what the goal, like what the best way to construct that is. So for the first statement, for example, some sector contains at least 5 points. Well, if you want to come up with a counterexample, you should try to evenly distribute the points as well as possible. Yeah, and then I guess it's very easy to come up with a counterexample to statement number 2, right? There it is right there. And of course, we're asking for, which of the following statements must be true. Statement 2 could be true for some distributions of points, but it's not true for all of them. And so it doesn't satisfy the conditions we're being asked for. Yeah, so nice little problem. If I have any mistakes, I'll let you know. Thanks for watching.